Hi class, today we start simultaneous equations. But for simultaneous equations, we have different methods. But here, I want us to look at elimination method. The time it takes a bit long because I just want to solve basically two problems for elimination method. 27 will be substitution method. Yeah, so later we shall be solving different cases, different level of difficulty. All right. The first one says, first of all, we want to find the values of x and y. Yeah, we need the values of x and y that will satisfy both equations. When we talk about simultaneous equation, of course, the word simultaneous is to do two or more things at a time. So solving two or more equations at a time is what we mean by what? Solving the equations simultaneously. The first thing we do is, first of all, we want to apply elimination method. Sometimes the examiner may be specific by saying, find the values of x or solve the simultaneous equations using elimination method. But suppose the instruction is not specific, you can go on and apply any of the methods you know or you are comfortable with. Now, the first thing we do applying elimination method is to label the equations. Now we say 2x plus 3y equal to 11. Let us call this equation 1. Then we say x minus y equal to 3. We call this equation 2. We are following elimination method. So I will make sure that the same way I explain here is the same way I'm going to explain when it comes to the second problem. So make sure you master the trend or the way the explanation is going. The first thing you do, identify the equations like this. Whenever you are a master of the topic, even if you don't label them, it doesn't matter. But whenever the teacher is teaching, the assumption is that the students do not understand simultaneous equations before. So my concern is always for the beginners. Whenever you are a master of every topic, you'll understand that there are different ways we can solve certain problems. All right, identify the equations. This equation 1, this equation 2. You can choose to swap them by writing this first before this, it doesn't matter. By writing this, labeling this equation 1 at the top, this comes below equation 2, it doesn't matter. Having labeled them equation 1 and 2, what is next? The next is ask yourself, there are two variables. We have x, we have y. You have to make sure that the variable that is here is here. X comes before y, and so it's supposed to be here again. X comes before y. So in that case, meaning x, x, y, y. And make sure that the constant terms are on the right hand side. Sometimes the teacher or the examiner may tend to do it like this. Yes, may tend to do it like this. But you want to apply elimination method. Make sure the terms of the variables are on the left, the constant terms are on the right. So you have to send it to the other side. Okay. Now we have this. What is next? Ask yourself this question. What is the coefficient of x for equation 1? It is 2. The coefficient of x is 1. The coefficient of y is plus 3. But for now, let us forget about the signs. Let's just go for the magnitude. We have 3 here, we have 1 here. We have 2, we have 1. Using elimination method, our target is that whatsoever we have here for x should be here. Meaning, what they have as coefficient must be equal, must be the same. Y here is 3, y here is 1. For the target, as far as elimination method is concerned, these must be the same. But my question here is, must these two be the same and also these two be the same? No, that is not the case. The case is that either the coefficient of x must be equal or the coefficient of y must be equal. If the coefficient of x are equal, even if the coefficient of y are not equal, no problem. We can go on. We are good to go. On the other way around again, if the coefficients of y are equal and the coefficients of x are not equal, we are also good to go. One of the variables, their coefficient must be equal for elimination method. Okay. Now, x2, x1 not equal, y3, y1 not equal, but one of them must, I underline the word must be equal, must be the same. Okay, I usually tell beginners that let us try to equalize the middle term. If you equalize this, no problem. These are the ones you make equal, no problem. So how do we make these ones equal? You can make them equal by multiplying equation 1 and equation 2 by any number of your choice, making sure that they will be equal at the end of the process. But mostly, the one that is mostly common is that this 3 we have here is brought here, and this 1 is brought here. This is the most common one. So you don't need to rack your brain again that, well, which number. Just take these 3 here, this 1 up there. So let's see what we do. Whatsoever we write here multiplies everything. This one multiplies everything. So 1 times 2x, 2x. 1 times 3y, 3y. 1 times 11, 11. So let's just name this equation 3. Though it is just the same, you can choose not to label it. By the time you would have become a master of the topic. Yes, we have different ways. You can have like more than 100, more than 500 students across the world that can solve this pair of simultaneous equation different way. Even if it is elimination method, we have different ways. But the most common ones across among the students, yeah, is what I'm portraying here. Again, 3 times x, 3x. 3 times minus y, minus 3y. 3 times 3 is 9. This is 4. Now, our aim of multiplying this one here, these 3 here, is to make sure that y coefficients are equal. Now, let's say you are not interested in making the coefficient of y equal. You want to make the coefficient of x equal. Well, this 2 is the one you multiply here. This one is the one you multiply here. The decision I just made here is that I want to make y the same, the coefficient of y. This 3 times here, 1 is multiplied here. Now, this one resulted to equation 3, 2 resulted to equation 4. Have we succeeded in making the coefficient of y equal? We can see 3, 3, yes, they are now equal. I will make sure that the same explanation is the one I'm going to also give to this one. Okay, now we've succeeded. But my question is, what if the question comes with equal coefficients here? Do we need to multiply? No, you don't need to multiply, because the essence of us multiplying is to make them equal. So if you are lucky enough, the question paper comes with, or the equations come with what? Equal coefficient, then it means you are one step ahead. Now we go, they are now equal. What is next? The particular terms with equal coefficients, look at their signs. The particular terms with equal coefficient, consider their signs, plus, minus, as to whether they are the same or they are different. If they are the same, what do? We subtract. If they are different, what do? We add. Mind you, I did not say if the signs are plus and minus. I did not say if the signs are plus, plus, or if the signs are minus, minus. I'm mentioning same or different. Okay, the signs in front of them are what? Are different. So what do? We add. But whether they are the same or not, having acknowledged that they are the same, we subtract. They are different, we add. The particular terms must go. The particular terms must go. But I'm sorry, before I had demonstrated this, I would have demonstrated first, but by the interpretation of this one, the signs in front of them are different. Plus, minus are different. So what do? We add. So meaning this and this are added. This and this are added. this and this are added. So having demonstrated this, the particular terms with equal coefficients, we cancel them. And this cancellation is the reason this method is labeled elimination method, meaning we have eliminated y. We have eliminated y. Now we are adding. When we are adding, it's different from when we are subtracting. Why? Because 4 plus 3, 3 plus 4, regardless of the order, we have the same. But 4 minus 3, 3 minus 4 will not give us the same. No, will not give us the same. So when we are adding, it doesn't matter whether we say the top plus the bottom or the second equation plus the first equation. It doesn't matter because we are adding. Addition is commutative, so that one will not be any problem. So 2x plus 3x is 5x equal to 11 plus 9 is 20. We are finding x and y. Sometimes in the process, you will get y before x, or sometimes you will get x before y. We need x, so we divide both sides by 5. So x is equal to, this is 4. We have 4. We've gotten x, it remains y. So what do? We say from equation, you have all the right to consider equation 1, equation 2, equation 3, equation 4 in order to find the remaining variable, which is y. Okay. But the reason most times we consider 1 and 2 because they are with smaller coefficients. There you can see here 1, here minus 1. But all these ones are occupied with more than 1. But it doesn't matter. If you consider any of these, you will get the same answer as someone who considers any of these. Okay, so we can consider what? Equation 2, from equation 2. I repeat, you can consider any of the 4 equations. You can even give it a try and see what you get. From equation 2. Equation 2 says x minus y equal to 3. Well, what is x? X is 4 already, so this x is now 4 minus y equal to 3. So we say 4, this 3 comes here, minus 3. Y goes to the other side. I decided to send y to the other side so that it will have a plus sign. But leaving it here, this goes to the other side, it doesn't matter again. You will still get the same thing as long as you can play with linear equations properly. So now we have y, which is equal to 4 minus 3 is 1. So x is 4, then y is 1. These are the values of x and y. These are the values of x and y. Now you want to know if your answers are correct before you submit to your teacher. Okay, how do you know that your answers are correct? Now let us look at equation 1, which is 2x plus 3y equal to 11. We want to prove that our answers are correct. On the right hand side, there is no x or no y. So let us avoid that one. Let us work on this. So we say 2 times x plus 3 times y. But what is x? X is 4. What is y? Y is 1. 2 times 4, 8. 3 times 1, 3. Then we get 11. If it satisfies one equation, but it doesn't satisfy the other equation, it is also wrong. Okay, let's see if it will satisfy the second equation, x minus y. X minus y equal to 3. But the right hand side, there is no x, no y. So let's forget about that. What is x? X is 4. Minus, what is y? Y is 1. 4 minus 1, 3, which is this. So this proves that our answers are correct. Okay, so this is elimination method for basic simultaneous equations. All right, so I'm going to the second equation, second problem. The second one says 3x minus 4y equal to minus 15. Then 5x minus 4y equal to minus 17. I guarantee you that I will give you the same explanation. Just pay attention. Okay. The first thing we do is to label them. This is our first equation. This is our second equation. As I said earlier, it doesn't mean that it is compulsory to name them. Yes, but I decided to go through all the procedures for someone who has never treated this one before to be able to solve basic simultaneous equations after these two problems. Okay. We have labeled them and we want to apply elimination method. The first thing is that we want x and x to be corresponded like this. See, they are occupying the same position. After which, y. You can even choose to swap them. It doesn't matter. For example, you say minus 4y plus x equal to minus 15. Then minus 4y plus 5x equal to minus. You will still get the same answer. The most important thing is applying elimination method. Xx. That is what we always want. Xy. That is what we've always wanted. Okay. Now we have labeled them, and XX same position, YY same position. The next thing is make sure that the constant terms are on the right hand side, and of course they are on the right hand side. Okay. So the next thing is we want to make sure that x coefficients are equal or y coefficients are equal. But we are so fortunate that this problem comes with equal coefficients. See, 4. I don't want to mention the sign, mind you. Okay, because I just want to maintain uniform explanation. 4. You can see the magnitude 4. They are the same. So do we need to multiply anything? No, we don't need to multiply. We usually do so to equalize one of the coefficient of one of the variables. So the fact that these are already equal, we don't multiply. We don't do that. Yes. But the question is, what if someone does that? What if someone multiplies? Well, it doesn't change anything. You will get the same thing. The only thing, you are growing what? You are growing the numbers. They become a bit larger or they become larger enough. Okay. Now they are equal. What do we do? Now go for the particular terms whose coefficients are equal. Which coefficient you made equal or which coefficient the problem comes with that are equal. And it's obvious that these are already equal. Now we are lucky on that side. What is next? What can you say about their signs? I mean the equal coefficients. Are the signs the same or the signs different? Same sign or different? If they are the same, what do? We subtract. Different, we add. I did not mention minus. I did not mention if the signs are minus, if the signs are plus. I'm saying if the signs are the same or different. So y has equal coefficient. The signs in front of them, are they the same or they are different? They are the same, minus, minus. So what do? We subtract. So this and this minus, this and this minus, this and this minus. But mind you, subtraction is different from addition. For addition, 10 plus 5 is 15. 5 plus 10, 15. Okay. But how about the subtraction? 10 minus 5, is it the same as 5 minus 10? No, they are not the same. So therefore, the condition here is when you are subtracting, if you choose to say equation 1 minus equation 2, you have to obey that everywhere. If you choose to say equation 2 minus equation 1, you have to obey that everywhere. You cannot say, for instance, here is 45. You cannot say, well, this is bigger than this. Let me say 5x minus 3x. this is bigger than, let me say this minus this. It doesn't work that way. Okay. So we are lucky that equation 2 has bigger. So we say this minus this, this minus this. But you can also decide to say this minus this, no problem. But you cannot say this minus this, then this minus this. You don't do that. But the particular terms that are equal, they always go, meaning we have eliminated y. The reason the method is called elimination method. Now 5x minus 3x is 2x equal to, okay, minus 17 minus 15. See, minus 17 minus 15. So these two signs, we separate them with bracket. So minus 17 minus is plus, then this is 15. So what do we get? We get minus 2. We need x. We divide both sides by 2. When you are divide the same numbers, we have 1. With this sign, negative 1. So it remains y. You can go to equation 1 or equation 2. So we say from equation 1, you can choose to select any or consider any of the two. Equation 1 says what? 3x minus 4y equal to minus 15. But x is already minus 1. So we say 3 times x. What is x? Minus 1. Can see it? Minus 4y equal to minus 15. This times this is minus 3 minus 4y minus 15. Okay? Minus 3, we move this one here, plus 15. This goes to the other side, 4y. Yeah, so 4y is equal to minus 3 plus 15 is 12. We need y, so we divide both sides by 4. So y is equal to 3. Okay, so that tells you that x is minus 1, y is 3. Okay, so thank you for watching. Don't forget to follow, like, share, and comment. Also subscribe to the YouTube channel.